Hello everyone. In this video, we're going to be solving a nice cubic equation. We have x squared minus x cubed equals 80, and we're going to be solving for x values. And I'll be presenting two methods. Quick commercial. If you like complex numbers, go ahead and check out my other channel, which is aplusbi. If you like algebra, then this is the channel for you. So let's go ahead and take a look at this equation. First method, the cubic formula. Do you know the cubic formula? Do you know how it works? Okay, let's take a look. So I'm going to go ahead and put everything on the right hand side, or actually I want to multiply both sides by -1. How about that? That's better. Great. So now we get a -80 and the left-hand side is negated. So they switch around. Make sense? Now, I'm going to go ahead and apply the cubic formula, but I don't want to have x squared in my equation. I can't have at least the method that I'll be presenting does not want x squared. So we need to get rid of x squared. And the way to do that is change the variable. A linear transformation will shift this graph. And we can do that by replacing x with something like y plus, and you just need to check the coefficient of x squared, because first it's a minus sign, so I have to negate it, which is a plus sign, and then the coefficient, the absolute value is 1, so 1 divided by the degree, which is 1/3. So if you replace x with y plus 1/3, that should give you a nicer equation. You'll see in a little bit why. Let me show you. So replace x with that, cube it, and then square it, and set it equal to -80. Right-hand side is a constant, so it's not going to change. Now, if you cube this, I usually cube it like this. I cube the first two terms. The first and second term, And then I do the 3ab thing, which is 3y 1/3, which is y, by the way, multiply by y plus 1/3. So it's just going to be y plus 1/3 multiplied by y. And this will become y squared plus y plus 1/4. Let's not write the right-hand side yet. So we're going to get y cubed plus 1/27. Plus, if you distribute the y, you're going to get y squared plus 1/3y minus y squared minus y minus 1/4. Everything must be negated. And of course, it's equal to -80. The constant term doesn't change with substitution because it's not a variable. Great. Now let's go ahead and simplify this. Y squared cancels out. Remember, I didn't want the square term, right? I didn't want x squared and I don't want y squared either. So now let's go ahead and put it together. We have y cubed. And then these two will give me -2/3 of y. And then we have two constants and another constant. So we kind of need to put these all together, like 1/27 minus 1/4 plus 80/1. And that's just going to give you a constant. But we want to put them on the right-hand side. So we rather write this as 1/4 minus 1/27 minus 80/1. The common denominator will be 4 times 27, which is 108. Multiply by 27, multiply by 4, and multiply by 108. You're going to get a very large number. Let's just call that C, okay? Don't worry about it too much because I'm just going to show you the method and the rest will be fairly easy, hopefully. So we have the following identity. A plus b cubed minus 3ab multiplied by a plus b equals a cubed plus b cubed. And remember, I used this before, right? So now we're going to go ahead and replace a plus b with y. And notice that a plus b is a solution of this equation. But guess what? Y is a solution. So y is a plus b. So whatever solution you get from here will be a plus b. So we need the values of a and b. What does that mean? It means that we can compare the coefficients of y here because these equations are equivalent, which means 3ab is 2/3 or ab is equal to 2/9. And a cubed plus b cubed is equal to c, whatever that constant is. But here's the whole idea. We're not going to solve it, but I'm just going to show you how to do it because it's going to be super boring and long and time consuming. Trust me. But I would still want to share with you the method, which was invented by an Italian guy. You name him, okay? Right. So, what can I do? I can cube both sides here. 8 over 729, right? And then from here, b cubed, I can isolate and write it as c minus a cubed. Remember, you know the numerical value of c once you evaluate it. Plug it in, you'll get a cubed times c minus a cubed. Remember, a cubed, you're solving for a here, and c is a constant, it's a given number. And now, when you distribute and put everything on the same side, you're going to get something like this. And when you do the substitution, a cubed equals d, or anything like that. Don't use c because I already used it. You're going to get d squared minus cd plus 8 over 729. Since you know the value of c, you can just solve the quadratic. That's going to give you the value of d, which will help you find a, which is the same as b. They're just going to switch around because there are two solutions, remember? And then we're just going to put these together, add them up as a plus b, and that will be the solution. So that's just the first method. Let's go ahead and take a look at the second method now, which I think will be very cool, but you get to decide which method you like better, okay? Cool. So here's how the second method works. I can definitely guess and check, right? If the solutions are nice. We haven't gone to the end, but hopefully you can finish that up and find the solutions. But here, one thing I can do is factor out x squared. And if the solution is nice, like an integer, then I can try to guess it, but it'll be an educated guess. So here's how it goes. We're going to factor 80, such that one of the factors is a perfect square, and the other one is supposed to be 1 minus square root of x squared, which is x, right? So let's go ahead and check out different ways of factoring 80. For example, 80 can be written as 1 times 80. If x squared is 1, that means x is 1, but 1 minus x won't be 80 in that case, because x needs to be negative 79, which is not going to work. So this is not good. What's the next factor, perfect square factor that goes into 80? That's 4. 4 times 20, again, x equals 2 or negative 2 will not work, right? So this is not going to work either. The next one is 16 because 9 doesn't go. 16 times 5. And if x squared is 16, that means x is 4 or negative 4, right? But if x is 4, 4 squared times 1 minus 4 is 16 times negative 3, which is negative 48. I need 80. So what am I supposed to do? Go with negative 4. Because if x is negative 4, negative 4 squared times 1 minus negative 4 is going to be 16 times 5, which is 80. Yay, Houston, we have a solution. And that is x equals negative 4. Great. But how do you find the other solutions? There's a way to do it. I'll show you. But before we get into that, you could also do the following. You could just write the equation like this and use the rational root theorem, which looks at factors of 80, but there are quite a few of them. Instead of looking at all factors of 80, look at smart factors, factors that are a perfect square times 1 minus the square root of that perfect square. Make sense? But positive and negative square root, by the way. Anyways, so that's rational root theorem. How do you find the other solutions? Once you know x is negative 4, factor theorem tells us x plus 4 is a factor if x equals negative 4 is a solution. So we're going to factor this in a special way like this. I'm going to add 4x squared to x cubed so that, do you see what I'm talking about? So that x plus 4 is a factor. And continue with minus 5x squared because I do need a negative x squared here. See that? I need to balance out. But then I need to follow by something like this, minus 20x. Once you do this a few times, you'll get used to it. It's going to be pretty much automatic. But then I don't have an x in the equation, so I kind of have to follow up with a positive 20x. Notice that these two cancel out, but don't cancel them out. And a plus 80 will seal the deal. Now, what do we have? We have this minus 5x times this plus 4 times the same thing. Notice that x plus 4 is a common factor, Yay, we have x squared minus 5x plus 4. The second factor looks factorable, but don't be misled. It's not. It kind of looks like if you switch the 4 and the 5, would it be factorable? I don't think so. You probably need a negative sign somewhere. I think x squared minus 4x minus 5 would be factorable. That's probably the only one. Or x squared plus 4x minus 5 should also be factorable, right? Yeah, exactly, both of them. Anyways, from here we get x equals negative 4. Obviously, that's the first solution we found. And from here with the quadratic formula, negative b plus minus the square root of b squared minus 4ac, b squared minus 16, right? Okay, divided by 2. And then those are going to give you the other solutions, I think. Anyways, let's check our work. Uh-oh, there seems to be one real solution. What happened? Okay, you know what? The two solutions are supposed to be complex, so I probably made a mistake. That's for you to find out. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care, and bye-bye.